Yeah, you see this flow chart, right? You see this flow chart. System design is the first thing that you need to know. Basically, system design will come. That's going to be the major part of the workshop. But mechanical design, electronics, and programming come together to make robots, right? That's all. That's all this slide says. These three things: mechanical design plus electronics plus programming equals a robot. Mechanical design, right? How do robots move? Wheeled, which are rolling motions. They're walking. They can do pick and place activities and many more, right? So the list is endless. They can do anything you can make them do, they will do for you, right? So let's get to, I think this section is all about wheeled robots. If you want me to go faster, please tell me so. These are all the different types of wheeled robots that exist, or the different types of wheel arrangements you can have in a robot, right? So this is called an Ackermann drive. And this is just like you see in a car, right? Where the front wheels are being steered and the robot can turn left or right by tilting the wheels. Okay, yeah, let's just watch this. I think it's about perfect. See, this is a great place to see. See, right? This is an Ackermann drive robot. See, that's the steering mechanism on an Ackermann drive, and you'll be able to look into how to build this sooner rather than later, right? This is the one of the most simplest drives. One forward and backward, and one steering mechanism is going to be there. So there's another one called an articulated drive, which is slightly more complex than an Ackermann drive. It basically involves two halves of the robot which can pivot around each other, and a linear actuator that can become longer and shorter, right? So this piece, this gray piece on the right, can become longer or shorter, and it can change the angle between the two halves. So if all the four wheels are rolling, by changing the size of this piece, or rather by stretching and compressing the piece, you can move the robot left or right, right? So it can rotate as well as travel forward and backward. It's called an articulated drive, right? Many space exploration modules use this because it's very reliable and you get exact control. Okay, so this is a pivot drive, pretty self-explanatory. So say the robot needs to turn to the right and is going straight, it will lower the platform, it will rotate, it will lift the wheels off the ground, and then the body will rotate to the right, and then the platform will go back up. So now the direction of the robot has been changed. Okay, this is an interesting type of drive. It's called the Omni drive, right? Which with four wheels you can move in any direction. There are many configurations for this Omni drive. One of the configurations you see is in the right in this picture, where you have one wheel on each side. What's unique about these wheels is that they can also rotate like wheels, but if you slide them sideways, the smaller wheels on these wheels can also rotate, right? So that's the good part about these wheels, and that's how they work, right? So the smaller rollers allow the wheel to roll freely along the direction, and the larger wheel has a motor under it, so it can actually power the robot, right? Right, so it's a very brilliantly designed drive. Both of these drives are Omni drives, except that the wheels are different. The left is a Mechanon wheel, while the right is an Omni wheel, right? So these are two arrangements which you can use. This is another pretty interesting video with the arrangement that I showed you in the image, right? It can draw any image you wanted to draw, right? So you see this. I'll just play a small clip of the video for you guys, and then you'll know what it's doing, right? So it's using the Omni wheels rotating, and by changing the speed of the wheels, it can change its direction at any time, right? So pencil up, pencil down action is there, and it can draw any shape that you want it to based on programming. So it'll draw a square, it'll draw a line, and I think the most impressive part is when it draws a circle, which is now, right? See the exactness of that circle, it's very accurate for something that's on wheels. Probably better than the human hand, right? This last part is probably what you'll be starting off with, right? This is called a differential drive, basically where there are two wheels or four wheels, which two wheels on each side controlled in the same way. By changing the speed and direction of each wheel, you can turn the robot. Basically, think of it as a circle, which you can rotate by moving the wheels in opposite directions, and which you can send forward or backward by moving the wheels in the same direction. These drives are very versatile, and they can be made with just two wheels on a robot. I mean, we'll have to obviously balance the robot with another two rollers, but those rollers can just move in any direction, so we don't have to worry about them. These are resources. You can check them out on your own time. The first one is a website which has mechanisms on it, 507 to be precise, and they're all animated. You get a fair idea of how they work, and you can try making these mechanisms out of cardboard, ply, or whatever materials you have at home, and try first with hand and then with motor. You can try actuating these mechanisms. And the second one is the tutorial section of the robotics website from IIT Kharagpur, and it's got tutorials on all types of robotics. So you'll see this link coming again and again. But it's got a fair amount of mechanical design tutorials as well, right? Let's move on to the electronics and electrical part. So electronics and electricals, basically they enable the robot and they energize the robot. So you can have the mechanism, but to make the mechanism move, you need to energize the mechanism, right? And that is how that is what electronics and electricals are there for, to enable the robot to control itself and to energize the robot, right? To put energy into the robot so that it can do some motions. So these are the four types of switches. So now the P means pole and T means throw, okay, in all four of these. So there's SPST, SPDT, DPST, and DPDT. So SPST is a single pole, single throw switch, right? So it basically can handle opening and closing of one wire in a circuit. And single pole double throw is basically it can handle opening and closing of one wire on the input and two wires on the output. So it can flip between 2 points. Basically, if you want to switch your energy from one side of the circuit to another, you'll use a single pole double throw switch, right? And then you have double pole single throw, which is basically opening and closing of two wires. And you have double pole double throw, right? Where you can open one side and you can use it and you can open another side as well. So you can control total 4 outputs with a double pole double throw switch. So these are the 4 types of switches. I think I'm going to skip a few steps here and move straight to double pole double throw switches and how they connect to a motor. So, okay, so imagine this, right? So let's say I push the switch towards A and B. It has 3 positions, as you can see. It has a 1 position, a 0 position, and a 2 position. On the left-hand side, you can see the 3 markings on the switch. So it has a 0 position, where the switch is flat. It has a 2 position, where the switch is on one side, and has a 1 position, where the switch is on the other side. So totally it has 3 positions, this switch, right? In 0 position, it's not connected to anything, right? But in position 2, C is connected to E and D is connected to F, right? You get it? C is connected to E and D is connected to F. Anybody like being left behind? I think this is a very big jump. So I think I'd expect that you have doubts here. If I move the switch to position 2, as it's shown in the figure, C is connected to E and D is connected to F. So how do you complete the circuit there? Power goes from plus to C to E, and that wire continues on to B and then to the motor. So plus is your right hand side of the motor, and consequently minus is your left hand side of the motor, correct? So now say I send my switch to position 1, right? Then C is connected to A and B is connected to D, right? So D is connected to B and C is connected to A. So now this flips the entire polarity of the motor and makes it rotate in the opposite direction. So basically connecting a double pole double throw switch in this way by cross connecting the 2 terminals on the outside and using the switch on the inside can allow you to control a DC motor fully, right? It can allow you to rotate it clockwise or rotate it anti-clockwise. So this thing we do here, we actually pull a wire from A to F and we actually pull a wire from E to B. This all connection is done outside the switch, right? So on these metal contacts that you see, the top left metal contact is connected with the bottom right metal contact, and the top right metal contact is connected with the bottom left metal contact, and then it's done. So this is called a cross connection. And then for the middle 2 contacts, we supply power, right? So if you do this whole connection and you connect any set of contacts to the motor, any top contacts or bottom contacts, if you connect them to the motor, then in one position the motor will move one way, in the other position the motor will move the other way. If you want, you can use your pen to trace the path of current from plus to minus, right? In each case, where C is connected to A and B is connected to D, that is case number 1. Case number 2 will be when C is connected to E and D is connected to F. So this is when I push the switch downwards, right? You can use your pencil or something to trace the path of the motor. Draw 6 points, draw a cross connection, and draw the motor connection to one of the terminals, and draw the battery connection to the middle 2 terminals. Once you do this, you'll see that if I connect the middle terminals with the top terminals, you'll get current flowing in one direction through the motor. And if I connect the middle terminals to the bottom terminals, it gets flipped and the current flows through the other direction through the motor, right? So you get both clockwise and anti-clockwise movements, right? So that is how this switch works. And this is probably going to be one of your first projects moving motors. Will be moving motors with a double pole, double throw switch. Right, so these are your resources. There's obviously robotics tutorials, and there's this fun website called Circuit Lab where you can make your own circuits and see how things work and just play around with components in general. You're all aware of many electronic components at this stage, so you can just check it out. So how do we program robots? So the microcontroller is the brain of the robot, right? It stores and executes instructions. When I say microcontroller here, you all worked with Arduino. Arduino is a good example of a microcontroller, right? It has connections for motors, it has connection for sensors, and it has obviously the brain to do all the computation and the thinking for the robot. The microcontroller is the brain of the robot. It stores and executes instructions. Coding these instructions in a programming language and flashing the microcontroller in machine understandable language. The programming language is designed for humans to understand, and machine understandable language is all zeros and ones. Humans cannot read it, right? But the machine can read it in binary, right? This is basically how we program robots. The key is that this instruction set has to be translated to a language which is understood by the microcontroller, whether it's Arduino, whether it's something else, whether it's AVR, Raspberry Pi. You have to translate this for the robot. So this translation is usually taken care of by the compiler, which you do on your laptop, right, or on your computer. Once you're done programming, you compile the code, take that small file and put it onto the robot. Robot understands what it has to do. So some platforms get you started. Obviously, a lot of you have heard of this, Arduino plus the Arduino integrated development environment, where you can code on the integrated development environment and flash it onto the Arduino. And if the Arduino has the right circuit around it, it will move the robot, right? So that is one. And if you're really getting serious about it, then there is also a Raspberry Pi, which you can code using Python. So basically, the Raspberry Pi is a full computer, and it has place for mouse, keyboard, monitor, and everything, which you can code, and you can run your robot off of. Yeah, so there are many tutorials here as well. Check them out. And yeah, programming is something that will only come the more you practice. So don't get disheartened. Program for at least a couple of months to know how good you are at it, because you have to really get started. The logic has to sit, and you need to be able to start thinking like in a computational manner, right? So you need to go step by step, instruction by instruction, and make sure it's all running right. So programming, there's only one way of getting good at it, is practice, 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 right? You need to get that logic in your head, and there are some resources for you to do it. We've done mechanical design, electronics, and programming, but with only these three things, you can't make a robot. So because you still have to design the system, right? You need to see what system the robot is going to solve for. You need to see where it's going to exist, what it's going to do. So system design is a major part of starting with robotics. System design basically tells you that you have to decide the entire system, all the components that go into the system. So if you're designing a self-driving car, now the car needs to do a few things. It needs to be able to sense the world around it, and needs to be able to go from one place to another. This is what a car does, right? So we have found a way of sensing the world around us, which is by camera or by proximity sensors, whatever. Now I have sensed the world around me. Now I need to go from place to place, right? What do I require from for going from place to place? So mechanical design is done. Wheels and drive we have, right? Electronic system is done. We have sensors, right? Third, programming. It needs to be able to make decisions on the road, right? So we need a programming setup that will make decisions for the car. Should I stop? Should I go? Should I turn left? Am I going straight? All these questions the programming has to answer, right? So the system design of an automated car will have a mechanical design consisting of motors and wheels, electronic setup consisting of sensors and power electronics and batteries, and a programming platform, or the programming of the car, which will consist of a decision making program. So these three things together make the system of the automated driving system. So system design, right? Brainstorming for solutions, to find problems and to solve for them. Both are part of the system design process. How to brainstorm, right? Decide on the questions to be answered. Build a problem statement. So basically, you'll have to build a problem statement. Back to this slide in a bit, right? Just hold on. Don't limit your ideas. There are no wrong answers. So, and I'd advise you to not tell each other that your idea is bad or anything of that sort. All ideas are good ideas, right? Because they will lead to something in the future of the brainstorming discussion, right? Ideas beget ideas. Build upon existing ideas and try to combine ideas and make them better. Quantity counts. Throw everything that you have in your head out there and let the team decide. And last is stay focused on the problem statement. Your brainstorming you should have your own internal filter before you throw out an idea. Being that, does this relate to the problem statement? I want to show you a video where it will show you that we can control individual atoms and we can make them move the way we want. So basically, it opens a lot of avenues for making custom designed materials, for making materials that can retain their memory, shape memory, all of these things, right? So, and this has a lot of applications in space. Let me just share my screen for a moment. It's called the world's smallest movie. Yeah, so as you can see, technology is really like advanced, and we have the ability to move individual atoms, and we're basically creating specific materials with very specific arrangements of atoms to give anything from strength to elasticity to heat resistance. There are many ways by which we can create new materials nowadays, and many of these materials are being used in robots. So that was kind of the point of this movie. So if you can scan the QR code, you will have a lot of content right in your Google Drive. So please use all the books to their maximum extent. A lot of them are school level, a lot of them are beyond school level, but nothing is stopping you from using the books.